Realism. I claim that idealism is more realistic than physicalism. The formal word for the study of reality is metaphysics. The aim is to describe the nature or character of all that fundamentally exists in our universe. This description should give a solid foundation for both our best understanding of ourselves as persons and also our best scientific understanding. I'm only considering two systems here, idealism and physicalism. In idealism, what fundamentally exists are minds which can perceive the world, and their only form of causation is agency. In physicalism, what fundamentally exists is more or less as described in our best current physics text, and causation is by means of physical laws. Both of these things are mathematical in character. Idealism and physicalism both have the advantage of being monist. Each asserts that the world is composed of only one kind of fundamental thing. Idealism says minds, and physicalism says electrons and such like. I'll show that. Idealism comes in many varieties, mostly bad. But a few, by no means all, are realistic, and these can, at least in principle, be made consistent with contemporary physics. Whereas physicalism can never be made at all realistic. First, I want to give an extremely brief introduction to physics. Newton's magnificent Principia was the first near-comprehensive physical theory. A page from this work explains mathematically the elliptical orbits of the planets around the Sun. He did this by giving a formula for the force acting between any two masses. Another showed how forces cause masses to accelerate. Newton's laws also predicted perturbations in the motions of planets, the tides, trajectories of thrown objects, and much else. For more than 2 centuries, Newton's theory seemed perfect. It gave an exact account of everything that occurred in the universe, as far as could be measured at that time. The special and general theories of relativity were the sole work of Albert Einstein. The account that relativity gives of time is more sophisticated than Newton's, but anyone who understands the maths will find relativistic time reasonable. Quantum theory. This is the most successful and accurate theory of all time, by a long way, yet it is the least understood. Some of these problems, such as superposition and entanglement, are merely weird. Richard Feynman once said, in effect, if you don't like them, go find another universe to live in. I'll describe these weirdnesses later. Others are just difficult. Time being classical leaves physicists with the difficult job of reconciling quantum theory with relativity. This is a standard task for theoretical physicists. More seriously, at least in my view, is that other problems are totally baffling, especially for physicalists, which almost all scientists are. First, measurement is primitive in quantum theory. But if we are made of physical stuff, shouldn't we be able to give an account of measurement in physical terms? No one has the least idea of how to do this. Second, the von Neumann split between the quantum system and the rest of the world, which is described classically. For example, on the left is a quantum system. We want to know its temperature, so we use a thermometer to probe this. The temperature is read when we look at the thermometer. It's usual to regard the von Neumann split as being next to the quantum system. We regard everything to the right of the split as being quasi-classical. This includes the thermometer. But we can regard the split as being to the right of the thermometer. Now the thermometer is part of the quantum system, and it can exist in a superposition of many temperatures. Only when the eye looks at the thermometer is a definite temperature seen. Why is the von Neumann split so utterly baffling? First, the split isn't a real part of the world. We place it in the world according to our imagination. Quantum theory gives the same result, in this case the temperature reading, no matter where we place the split. Can a thermometer really exist in a superposition of states? Giving a principled answer one way or another is an unsolved problem. Pushkin says, these baffling features led there to be many different interpretations, or ways that scientists try to understand quantum theory. The Copenhagen interpretation says crudely, we should give up trying to understand the universe. Instead, we should be content to predict the results of experiments. John Stuart Bell was scathing. He said,
"The aim remains to understand the world. To restrict quantum mechanics to be exclusively about piddling laboratory operations is to betray the great enterprise. A serious formulation will not exclude the big world outside the laboratory."
Many worlds asserts crudely that the fundamental ontology is just the wave function psi, which never reduces. It just flows linearly over configuration space over all time. Somehow you're supposed to derive physics from psi alone. Noted philosopher and scientist Abner Shimoni is highly critical. He says,
if you don't have physical data, you're not going to get a quantum mechanics. You're not going to get any physical theory at all. So if you have a physical theory, as quantum mechanics is now constituted, the dynamics being a unitary dynamics which preserves superpositions, you don't get data. You get no experimental results. Therefore, you can't close the circle.
There are many other interpretations, all with severe difficulties. Now we return to metaphysics. I'm going to describe physicalism in extremely broad terms. The universe proceeds from physical state to physical state according to physical laws. Chemistry is grounded in physics, and all chemical laws are reducible, at least in principle, to physical laws. Likewise, in principle, all biology is ultimately reducible to physics. The only true causation is by means of physical laws. A person who claims that any feature of our universe is strongly emergent is thereby denying physicalism. Physicalism's difficulties with the mind-body problem are long-standing and well-known, but I'll defer the critique of physicalism until the end of the video. Panpsychism is a form of physicalism. It asserts that everything that exists, electrons, molecules, plants, animals, etc., has mental properties. This is in addition to their physical properties. Panpsychism solves some aspects of the mind-body problem. There's no longer any need to explain how mind emerged, seemingly from nowhere over the course of evolution. Likewise, during an animal's development from a fertilized egg. Mind, in primitive form, is omnipresent from the Big Bang. But other problems remain. How do mental properties relate to physical properties? And don't physical properties do all the causal work? Now we come to our other metaphysical system, idealism. Recall that, according to idealism, what fundamentally exists are minds. And the only form of causation is agency. Idealism comes in many varieties, each with its own distinct features. Here, I'm mostly going to discuss my version, called Pan-Idealism. First, Pan-Idealism combines panpsychism with idealism. Consider every individual thing, X, that exists in our universe, according to our best current physics texts. Whereas panpsychism claims that every X has mental properties, Pan-Idealism claims that every X is a mind. According to me, even a rock is a particularly trivial mind. Many panpsychists are squeamish about this. But a place setting isn't a mind because it isn't an individual thing. As we'll see, Pan-Idealism is indeed a form of idealism. And all physics is secondary and is entirely derived from mind. Next, every mind has a rich percept. Even an elementary particle such as an electron has such a percept. The percept exists without any need for sense organs. This may seem bizarre, or even worse, but I'll provide several good arguments for this later on. Some structures within the percept are manifestations of other minds. These minds are neighbours of the electron. Because neighbours is a spatial and hence physical term, this only becomes apparent after synthesizing the physics, which I'll show now. Here's a short film. Imagine a toy universe in the shape of a cube. The cube contains particles of two types. Particles I'll call wood make up the shape of the chair, and particles I'll call air surround the chair. We can describe it according to three metaphysical systems, or ontologies. Physicalists would claim that this universe could concretely or actually exist. In this and later pictures, I've highlighted in yellow everything that concretely exists. But how does this supposedly concretely existing universe differ from its abstract mathematical model? The answer is not at all. This motivates panpsychism, the position that every entity has at least some mental properties. The percepts of a few of the multitude of air particles are sketched below. These percepts are not marked in yellow because they are not extra entities. Rather, they are extra properties of the entities that have already been highlighted. I've not shown here the percepts of the wood particles that make up the chair simply because they're difficult to draw. In my position, Pan-Idealism, the ontology is reversed as shown in yellow. Now what fundamentally and concretely exists are minds. This is a huge metaphysical shift. Whereas before, everything was grounded in the physical, now everything is fundamentally grounded in mind. In Pan-Idealism, the physical world is, by definition, the best possible synthesis of mathematical structural information taken from the percepts of all minds. This exists as a purely mathematical fact, but you can regard it as being a bit like putting together a vast jigsaw puzzle. The physical world is entirely secondary. Despite being an abstract mathematical object, the physical world is real. Given all the jigsaw pieces, there's only one valid picture that can be made. In panidealism, the physical world isn't a mere whimsical notion. It's possible to synthesize time from percepts in a somewhat similar manner, but I won't do this here. Next, agency is the only form of causation in panidealism. John Searle demonstrates agent causation.
The current mantra is the physical world is causally closed. Well, you want to watch and see how consciousness makes a difference to the physical world. I decide to raise my arm and the damn thing goes up.
So the sequence is: John decides to raise his arm. He then perceives that his arm is above his head. Minds around him perceive that his arm is above his head. But, in contrast to Searle, agency and perception aren't restricted to biological systems. Although they cannot think, even air molecules have these faculties. Physical laws in panidealism. These facts have already been discussed. Physical laws do not amount to causes. David Hume and Bertrand Russell both pointed this out. It's more correct to say that laws are excellent descriptions of the propensities of minds to act. How can minds combine to form a unitary mind? Here is a bad argument. Electrons are like little billiard balls. So they can only combine like billiard balls. In particular, electrons cannot combine into a single entity with one unified state. In other words, they cannot become entangled. This is a bad argument. Electrons are fundamental. They can combine in any way that is according to their nature. Somewhat similarly, in panidealism, minds are fundamental. There can be no a priori restrictions on the way several minds can combine into a single mind of arbitrarily greater complexity. To minds that observe it, this mind will be perceived as an entangled system of particles. Such entangled systems are capable of an astonishing richness of behavior. My book gives more specific detail about physics in panidealism. The credibility of panidealism. First, the credibility of idealism. Physics isn't present in the fundamental ontology. This is reasonable because our only access to the world is through our perceptions. There's no way to peek through the veil of perception to give us direct access to the world. So our sole access to the universe is through our percepts and agency. This includes all of science. It follows that everything can, in principle, be reduced entirely to mentalistic terms. Second, the credibility of panpsychism. As we've already seen, panpsychism solves some of the difficulties of the mind-body problem. But some remain. Suppose each particle can only have a flicker of mentality, say a tiny tickle. How can many such particles possibly combine into a sophisticated mind? Abner Shimoni had these reservations.
What do we know of the experience of an electron that allows us to use the word experience and apply it to the electron and ourselves without absolute equivocation.
Is it possible that a single particle can have an accurate percept of its surroundings? I hope to show this idea isn't as absurd as it first appears. Here's an interferometer experiment with 3 detectors. The intensity of the light observed at each detector is shown. These intensities depend on the position of the upper detector. The intensity of the laser can be turned down so that only a single photon is in the apparatus at any time. In this case, the results are proportional to photon counts. How are we to explain this? My claim is that the wave function psi represents a photon's percept of the apparatus. It also encodes each photon's propensity to act. Our human percept of the lab is more or less sketched if we ignore the waves. The photon's percept psi also contains information about the contents of the lab. If the highlighted mirror is rotated, then the direction that the reflective photon is likely to travel will also be rotated. Scientists standardly plot the progress of psi through the apparatus, either using ray tracing or, most elaborately, using quantum electrodynamics. In his book on quantum electrodynamics, Richard Feynman does say, "So light doesn't really travel only in a straight line. It smells the neighboring paths around it." He held philosophy to be worthless, but make of his words what you will. Next, the credibility of pan-idealism. The photons and all the apparatus are real, but they are, respectively, unthinking minds or trivial systems of such minds. Each photon possesses primitive agency, a wanton freedom to act according to its percept of the apparatus. The so-called born rule does not determine how a given photon will act on a particular occasion. It merely describes the statistics of many such wanton free choices in the long run. Complex systems can evolve to possess both reason and genuine, in technical terms libertarian, free will. You can evaluate for yourself the credibility of pan-idealism with the believability or otherwise of typical interpretations of quantum theory. The Copenhagen interpretation provides no ontology or model of the world. In effect, is just shut up and calculate. As Abner Shimoni discussed, many worlds has no empirical content. Many popular science accounts are wildly implausible. A particle transmogrifies into a wave when not being observed. Bohmian mechanics has a quasi-classical physicalist ontology. For this reason, it cannot give a persuasive account of the mind-body problem. The behavior of every particle of your brain has been predetermined ever since the Big Bang. Spontaneous collapse interpretations can be readily adapted to pan-idealism. Finally, pan-idealism gives us a better understanding of the von Neumann split. Rather than being a dubious boundary in the physics of the world, the split represents the limited percept of a single mind. This is hinted at by the boundary of the thinks bubble. Minds are plentiful throughout the universe, even in the quantum vacuum of space. There are also many sealed in the box, along with Schrödinger's unfortunate cat. Professor Shimoni's position is closely related to pan-idealism, so we'll examine it now. Roger Penrose set out his views on both physics and the mind-body problem in this 1997 book. There were responses from 3 academics, including Professor Shimoni. He was a considerable philosopher and physicist. He is famous as one of the quartet of physicists who developed the CH-SH inequality, a more practicable variant of Bell's inequality in quantum physics. Professor Shimoni writes, A.N. Whitehead's philosophy of organism, which has Leibniz's monadology as an antecedent, has a mentalistic ontology. Its ultimate entities are actual occasions, which are not enduring entities, but spatio-temporal quanta, each endowed, usually on a very low level, with mentalistic characteristics like experience, subjective immediacy, and appetition, by which he means primitive volition. Roger Penrose responds, I find Abner's modernized Whiteheadianism particularly striking, with a suggestive plausibility about it. I realize now that the kind of thing that I must have been at the back of my mind is very close to what Abner so eloquently expresses. Moreover, he is right that large-scale entanglements are necessary for the unity of a single mind. Although I hadn't explicitly asserted, in either Emperor's New Mind or Shadows, the need for mentality to be ontologically fundamental in our universe, I think that something of this nature is indeed necessary. In chapter 19 of this book, Abner gives a detailed account of his position. As we saw, later in life he retreated, on the grounds that the percepts of particles must be trivial. But here I've made the case that even a single particle has a rich percept of its surroundings. Finally, I'm going to compare physicalism with pan-idealism. The floor shows what is fundamental, and the wall shows what is secondary. In physicalism, the foundations are described in our best physics texts. The astonishing success of science has led almost all scientists to be physicalists. But physicalism gives an abstract mathematical picture of the world. Here's a problem. Suppose you're given a mathematical model, say written as equations in a vast book. Is it instantiated as a concretely existing universe, or is it merely a mathematical abstraction? This question seems impossible to answer without sneaking in some concept of mind into the mathematical foundation. I call this the problem of physicalist instantiation. This quote by Roger Penrose is relevant to the problem of instantiation. I'll leave you to read it for yourself. Now to secondary matters. The physicalist mind-body problem has proved to be intractable for more than a century. Many conflicting solutions have been proposed, but none has been widely accepted. Despite intensive study, there is no plausible solution in sight. Next, we turn to pan-idealism. This is grounded in what we are most familiar with and certain about, our percepts and our agency. I've also argued that it is at least reasonable that particles are simple minds that can combine. On this foundation, there's no problem in deriving all of physics in mentalistic terms. If we just consider human minds to date, then this physics is our provisional current physics. If we consider all minds, both great and small, over all time, then this is the true physics of the universe. It's sometimes called completed physics. In pan-idealism, This true physics is a mathematical fact about relationships between the percepts and volitions of all minds. To sum up, physicalism has two major problems that panidealism does not have. These are the mind-body problem and the problem of instantiation. Some problems remain common to both, such as the problem of qualia. But panidealism is far superior to and is more realistic than physicalism.